Okay, so now we are gonna learn about the theory part, which is those definitions, and those definitions are really the key to the advancement of fluids, because there is Bernoulli's theorem, there is continuity equation which you need to know, and I am also studying, so of course I can be wrong at some times, but I have read some books, and from there I have summarized this. So if I am wrong, then please let me know. I will rectify myself and I will do the corrections in the video. Okay, first we get to types now. Types of fluid. We are studying fluid kinematics, so of course there are going to be types of fluids. So the first type of fluid is steady fluid, or types of flow, you can say. Steady flow. What is steady flow? Steady flow is when the field variables, right? Now we are using the word field variables. We will use it, okay? When field variables, and when I say field variables, you have to know that I am talking about pressure, I am talking about velocity, I am talking about density. When field variables are not changing with respect to time, then they are called steady flow. Now what does this mean? See, we take again this cube. Now you should know that this is an elementary cube or elementary structure, okay, geometric structure, and fluid is passing through this, okay. Now here it is said that when field variables are not changing with respect to time. See, this is the factor here. So see, suppose at this point, okay, at this point, see, this is t equals to 5, okay. At t equals to 5, any fluid which is passing through here, at t equals to 5 at a particular time, any fluid particle passing through here, their velocity or their pressure or their any other parameters are same, okay. They are not changing with respect to time, because here dp dt or dv dt are same, ds dt, they're all same, they're all 0. dp dt, dv dt, everything is 0, because there is no change with respect to time, so they are all 0, okay. dp dt, these are for example, okay. dv dt is 0, because this is a constant time. At t equals to 5, at t equals to 10, at t equals to 3, at t equals to 2, it's all 0. Now the non-steady flow or unsteady flow, here this same thing happens, but they change with respect to time, okay. Now see, like if this same thing, if at t equals to 5, okay, a particle comes here with velocity 10 meter per second, here again a particle comes here with 5 meter per second, 2 meter per second, 7 meter per second, pressure is 10 pascal, 5 pascal, 6 pascal, like this, it changes at every time, so dp dt is something, it gives some value, dv dt gives some value, it's not 0, because dp dt or dv dt is, if it's 0, which means p, v are constant, right? We know this, that's why. So this is the same thing here, okay. Now we get uniform flow. Uniform flow is when field variables are not changing with respect to space, they are called uniform flow. Like we take this is the fluid, and suppose here the pressure is 10 pascal, velocity is 2 meter per second, okay. Fluids passing here. If we see the velocity of this particle here, right here, okay, then we will see that the pressure, the velocity is same of this particle too, this particle too, this particle, every particle here is the same, and the field variables does not change with respect to time. They do not change, with respect to space, I'm really sorry, with respect to space. Any particle here, everyone's velocity is 2 meter per second and 10 pascal, 6 pascal, 7 pascal, 8 pascal. Everyone, if a particle's here in this particular structure, if a particle's pressure, particle is experiencing a pressure of 2 pascal, every particle in this structure will experience 2 pascal. Velocity, if it experiences 2 meter per second, every particle in this structure will experience 2 meter per second. Okay. Now the opposite of this is non-uniform. Here the field variables change with respect to time. Okay, here the field variables change with respect to time. The velocity pressure here, the velocity pressure here, the acceleration here, everything is changing. Okay, everything is changing. Acceleration, like if it is 15 meter per second, so everything is changing. Okay, nice. So these are the things. And also here is 5. Here is laminar flow. Laminar flow, yeah. You may have seen videos like this, like from a tap water, some water is flowing, but it's like it's really still. It looks like it's really still, but when you touch it, then you see that it's flowing. But again, if you remove your finger, then you see that it's again still. It looks still, but it's not. What happens? It's laminar flow. Okay, here, like you have seen, for example, in parade, right? In army parade, when they go in a flow, they go in a steady and parallel way, right? They go parallelly and in a straight manner, but they don't overlap or they don't intersect each other's path, right? Otherwise that will be bad, that will look bad. So yeah, it's laminar flow. That's laminar motion, it's laminar flow. The same thing, it's laminar flow. It's straight and parallel. It's literally it, straight and parallel. That's it. That's how laminar flow is. Like when the water flows, the particles, they are on the line, like this, on a very conducted manner, on a very smooth manner. They go, like the particle are like this, they flow like this, they don't overlap on each other. Okay, they flow like this, line by line, in a very good way, in a good manner. Okay, enough talking with the flows. Again, Ocha, we have some other flows too. This is the laminar flow, and the opposite of this is, we have it, the opposite of this is turbulent flow. Turbulent flow is nothing but this. It has anything. It's not parallel, it's not straight, it's not steady, it's not uniform, it's not laminar, it's nothing. Okay, it's nothing. It's just it. And we can't find anything, we can't determine or estimate any position of flow or of a particle here, because it's turbulent. It has nothing to follow, no trace to follow, no lead to follow. How can I make an equation from here? Yeah, pretty much it. So after this we get to the last part of this video, which is compressible liquid, compressible fluid or flow, anything. Here the fluid which is flowing through here, compressible fluid means the density changes. Okay, the density changes, we can change the density. Yeah, that's it. That's what you all need to know.